We've talked about how to define a class, and we've tried to give you a visualization of it. Let's go back and look at it again, using things we used earlier in the class, particularly that idea of an environment or a frame for storing information. So let's walk that through, and here's the way to think about it. When we define a class, we say class, coordinate, some arguments, and then some attributes. What that does is it creates a binding of the class name, in this case coordinate, up in the global environment. This is that big top-level environment to which Python's always talking. It creates a binding of that name to a new frame, right there. So when I do class of something, it creates a new frame. Inside that frame, we bind attributes. So that's where those definitions go. So if we have a method that is stored inside that frame, for example, defining a init creates a new procedure. So a init in this frame points to procedure object, and that has a body in here that tells us things to do, and that procedure knows about the frame in which it was created. So this says a coordinate is a reference we have up in the top level. It points to a frame, and inside that frame we're going to have attributes. Now, those attributes could be, as we've seen here, procedure. They could also be instance variables. So variables are local procedures. They're stored inside of an attribute. And notice that the frame knows the parent environment from which it can inherit. So it knows right here that it came from that initial frame. So in this case, for coordinate, the only attribute we had was the method. So there's a binding of the name to a procedure. But if a class definition also bound local variables as part of its definition, then those would also be bound in this frame. So we might have foobar bound to 5 if that was also part of the definition of coordinate as a class. So the frame here, representing the class, has all of the local attributes of the class, not of the instance, of the class. Okay, we can access parts of a class by using a particular format. In particular, shown right here. So what does this say? This says, get the value of coordinate in the global frame. There it is. It's pointing to a new frame. And the dot says, inside that new frame, look up the value of this binding. There it is. And it's pointing to a procedure. So we can use as many sequences as we need, depending on how deep the chain goes, of dot notations to get out the pieces we want. So coordinate dot under init under says, get me the init method associated with coordinate in this frame. And that's exactly what it does. It now gives me back a procedure, which I could then use. And we use standard rules for looking up the value of the next part of an expression in any frame. Okay, now let's suppose we actually invoke the class. We call the class method, which we do right here. We're going to bind C in the global coordinate system, or global frame, to whatever we get by evaluating this expression. So what's the value of that expression? Well, that is a name. We look it up in the global frame, and it's got a binding. It's a new frame. Great. That new frame now has an init method. Because it's a class, I'm going to use the init method on this instance. Before I do that, though, by calling coordinate, which is a class, it's going to create a new frame right down here, which is going to be the instance. That is what's going to be created every time we invoke coordinate. It creates a new instance. Now, that's going to store the information the way that we want. And once this new frame is created, then we call the init method. So there's the instance. Having used coordinate to instantiate that, we now get the init method looking in this frame right here. There it is. It's pointing to that procedure. And so that init method is now called. And remember, it's got an argument self, so it's going to point to that instance. And in fact, we can think about what a procedure application would do. It would create a new frame with a variable associated with each of the variables of its definition. And so self, Python is going to have pointing back to the instance. It's going to bind x in this frame. It's going to bind y in this frame. And those are going to be bound to the values passed in, which were over here. Now, relative to that frame, this procedure just runs like it was any ordinary procedure. It says get a value for self, or rather find a name for self.x, and I'm going to use that to bind to the value of x. So it says where's self? Pointing there. And in there, I'm going to bind x to the value associated with x in this frame. So I'm going to create a 3 there, and I'm going to create a binding for y. Sorry, that didn't work out very well. A 4 there. And I will, when I'm done with that, I'm going to return that. I'll do that in a second, but notice that the instance knows about the frame in which init was called. It has information that keeps that around. So there's a chain here that I'm going to be able to use when I want to access information as I move forward. Okay, as we said, evaluating the body creates that particular set of instantiations. And so now, what we can do with this format is we've now got a fully instantiated instance. There's the instance. This will get garbage collected because I'm not going to need it anymore. There's the instance. It is an instance of coordinate, and it has some local attributes bound to it. Great! That's what I need. Now, that, in fact, is what's returned by this. That's the value of that call, and that lets me then do the last piece, which is I bind the name C from this call up here in the global environment to that instance. And that's great, because now C points to an instance of a coordinate. And if I wanted to get values out for C, I could do them, right? And in fact, let's think about exactly how that would happen. If I do that, I could get the value of any attribute of C, because I got local binding. So in particular, if I say, what's the value of C dot X? I'm talking to this global frame. There's the value of C. It is bound to a new frame. And this then says, what's the value of X in that frame? Oh, cool. There it is. Look it up, return it. And you can imagine, if I had other instances, they would point to different frames. So there's not going to be confusion about which value of X I want to use. There's some other things I can do with this. And just to give you a sense of that, C has access to any binding in the chain of environments. So C points to this instance down here. So it certainly knows about X and Y. But I could also, if I wanted to, be really funky. Let's apply C.init to some new arguments. Now this is actually breaking, in some sense, my boundaries, but I want you to see what would happen if I do that. So where's C? It's bound up here. I'm talking to that frame. I get that new frame. And in there I say, what's the value of init? Well, it's not bound here, but because I know the chain from which it came, I can look up there and go, oh, there's init. It's a procedure. So I'm going to return that procedure, and that's copacetic because I'm now going to apply it to two new arguments. And I'm going to therefore go ahead and call this procedure in order to create whatever should happen. Now I actually cheated here. I showed it as changing the values to 5 and 6 here, but in fact calling that procedure would probably create a new frame in which we would bind 5 and 6. It depends on the version of Python and how we do this. But either way, the point I want you to see is I can get to that init method and call it if I wish. Okay, the other key thing I want you to see here when we think about environments is if I were to now go and call, as I did before, origin to be coordinate, exactly the same process follows. I'm going to create a binding of origin. It's going to point to a frame, this one down here. And notice, now I've got a frame, an instance, with values for X and Y. I've got a different frame or instance with values of X and Y. And they are separate. So there's no confusion about which value I'm getting when I ask an instance for its value. That's a very mechanistic way of thinking about it, but this environment view gives you a sense of the process. When I call a class, I instantiate it. That class points to a frame, and that instantiation creates an instance. Within, or using that instance as an argument for self, I call any init method, and that will in fact then do some work to create variables, in this case instant variables or attributes for each of the instances. And when I've done that instantiation, the instance itself is returned as the value so that I can give it a name. We'll move on now to thinking about how we use this.